and do a few questions here. So it won't be as interactive today because I feel like I'm just gonna. This is my last chance to get stuff hopefully to stick, and so I'm just gonna go here. Okay. So I'm gonna do a little bit of trig. I will do trig first, and then I will dive into the chapter 6 and 7, which we have actually done quite a bit of. Okay, chapter 6 and 7 we have done. I'm not going to solve a triangle because I feel like from what I'm seeing on your tests, it's word problems that are challenging to actually provide a diagram that is accurate and that actually represents the question. And I get it, word problems are difficult, but maybe some terminology that you need to remember is the direct distance, okay? So I'm going to give you a prelude here. Technically, the angle of depression, right? Like, so you imagine, right, somebody, an animal or somebody is on the tree, right? And so this is the ground. And you're mentioning an angle of depression to something down here, okay? If you're coming from up here and they're mentioning an angle of depression, folks, the direct distance to that object is this line, in this case the diagonal. That's the straight line distance, right? That would be from the top of the tree straight down to that object that you're seeing on the ground. So think of the diagonal, and now think of a rectangle that is actually here as well, with two triangles that are exactly the same. Okay, so angle of depression, I would like you to think of a triangle that is upside down, right? And the angle of depression is up here. This is the angle of depression. Okay, there's another triangle, and you have to choose one that you're going to work with. That is here. Okay, they're identical. Okay, and so this is the angle of elevation here, right? So the direct distance is, this is the direct distance. This is the horizontal distance. And this is the height. Now, technically, this is height and this is height. It's just like a rectangle, right? The width is the width. The horizontal distance is also happening twice because you're basically copying the triangle over, okay? Please do not put, a lot of you are graphing this. Sorry, I almost flunked art, okay? So don't make fun of my graphing here. A lot of you are doing this. You're like, yeah, okay, got, up on the tree, looking down at this, and you graph it like this, and you put your angle of depression there. That is wrong, okay? It's not like that. Remember, it's always between the horizontal. You have to, if it's not there, make a dashed line. This should be there, okay? And here's something else that is, some of you have noticed, some of you didn't care, okay? And I don't blame you. But here's something cool, okay? Let's say the angle of depression is 30 degrees. Let's pick an easy number. Let's say it's 30. You would then graph your triangle like this, and you'd say this is 30. It's between the horizontal and the diagonal, okay? So no big deal, good. Now let's make that second triangle. Let's make a rectangle out of this question. Okay, Francine, there's a course evaluation that I would love for you to fill out later on. Okay, it's anonymous. Okay, so there's a triangle there, but let's make this a rectangle. Let's copy this one over. So your 90 is here. Watch this. This is going to be, some of you, it's going to blow your minds. Okay, if this is 30 here, and a rectangle, I know this corner is 90. So if this is 30, then this must be 60 here. right? I just found out by going 90 minus 30, I get 60 there. Okay, now let's look at this triangle. So there's a triangle here, okay, and there's a triangle over here. I need you to understand that maybe for next year it will also come in handy. Okay, you have, but they're exactly the same, except for they're not, that doesn't look like it, right? If this is 60, if I deal with this triangle right here, this is my first triangle, this is my second triangle. This is technically the angle of elevation. We would consider this an angle of elevation. What would that be, that measure? Well, I know that the sum of all angles in this triangle is 180. Take away the 90. Take away the 60. What do you end up with? 180 minus 90 is 90. Minus 60 is 30. Right? So this angle here is 30, which is the same as that one over there. So the angle of elevation is going to be equal to the angle of elevation. Angle of depression, angle of elevation measure the same in a word problem. You just got to make sure you plug it in the right place. Right? If you want to work with this one, I would say you should start your diagram and label the angle of elevation there, and then you can bring it over to that triangle there, which is really the triangle at the top rotated. So let's summarize. In conclusion, if this is 40 here, which is the angle of depression, you know that this is going to be 40 as well. You know. You just got to make sure you don't put the 40 in here, right? It's angle of depression is there, angle of elevation is here. So you need to know where they go, but they are going to measure the same, okay? Because it's basically, if you were to turn this one, right, rotate it, you would end up with a 40 here. So remember that, okay? So you could also use the angle of depression, label it, and then subtract that from 90 to get this angle. And this angle is just an acute angle, the 60 here, but it's not the angle of a depression. You need to know that, okay? Because if you don't get it right, the whole question will be wrong if you don't know where the angle of depression is. Okay, let's do some solving here. Let's do that word problem. Okay. Here, two office towers are 50 meters apart. Okay. And we know that from the 14th floor of the shorter tower. Okay. So this gives it away that there's a taller and a shorter tower. The angle of elevation to the top of the taller tower is 33 degrees. The angle of depression from the 14th floor to the base of the taller tower is 39. Determine the height of the taller tower. Include a labeled diagram. Okay. So let's draw this. Okay. I'm going to use a ruler. We have our ground. Let's make a long line which represents the ground. Some of you already did this, so good for you. You have the shorter tower, right? And you have the taller tower. So make sure we know the difference here. Okay? So shorter, taller. We can call this A, we can call this B if you'd like. And we know that the distance between them is 50 meters. This should ring a bell on the test, right? We did this. And what's up with the 14th floor deal? Does it matter? They could have said from the first floor, third floor. It doesn't matter. So 14th floor, let's assume this building has 20 floors. From the 14th, let's make this it, right? And so basically that's the horizontal that we're going to use. And it says that the angle of elevation to the taller tower is 33, right? Angle of elevation. So from here, from the 14th floor to the top of the taller tower, the angle of elevation is formed between the horizontal and the diagonal going up. So this is 33 degrees right there. Okay. And then it says the angle of depression from the same point, right? It's still the 14th floor to the base of the taller tower is 39. So this is not drawn to scale, as you can tell, but I'm gonna go like that. Should have used a ruler. This angle right here is 39 degrees. Okay. So you have two right triangles, and that's what you expect to see. We have that, so I'm going to call this distance from here to here x. I'm going to call the distance from here to the top y. And of course, z is going to be the whole, it's going to be ultimately what this question is asking me for. So that's x plus y, right? If I add up this and that, I get the tower, the taller tower, right, in its entirety. So you can go 1 and 2 if you want, or just say solve for x, and I will make a diagram here quickly. Doesn't take long, right? Just with the basics. I know that this is 39, this is x, and this horizontal line here, the side that they share, remember, you normally start with a triangle, the triangle that has most of the information. In this case, they both have the same. This line that splits them is 50, right? We just transfer it over. So this is 50 over here. So opposite, well done, folks. All of you were labeling was very well done, okay? So I must say that. Like, I don't know if you took trig before, I don't know, but you were doing good. So opposite and adjacent, that's TOA. So tan of 39 degrees, make sure it's always glued, tan, cosine, and sine glued to an angle. If you don't know the number, it has to be a letter. There has to be a letter taking its place, okay? Or theta, right? Tan is opposite over adjacent. Very important to get this right. And in this case, you cross multiply, right? There's a 1 here. So 50 times tan of 39 is equal to 1 times x. And so x is just, I don't know what the answer is. I didn't peek, even though you know, right? This is 40.4892. And we are in meters. And the reason why I'm rounding to 4 is because I'm going to need it. What I liked, some of you write the 4 decimals, but then you also, if they had asked for the height, they could have asked for what's the height from the ground to that 14th floor. Then you technically x is part of your answer. So you can say, hey, 48, 49 meters, that's technically the answer. That's the height to the 14th floor, right? If they had asked that, but they didn't. So I'm going to use this as to continue my work. Solve y. Thank you for organizing your work so well. Okay, folks, I like that. Right? So we work with this one. This is 50, this is 33, and this is y. It's again TOA, right? Opposite, adjacent. And this is my don't know, don't care side. So I need to use tan. I'm just going to go ahead and do that. 33 is opposite over 50. And so y is equal to 50 times tan of 33. Y is equal to 50 times, and that's 32.4704 meters. So important to me, okay? Now Z is really answering the question, the height of the tallest tower. So that's x plus y, which is 40.4892 plus 32.4704. Some of you got lucky, okay, and you did only use 2 decimals, and it did not affect the final answer. But if it does, you will see something called RE, right? Round early. That's half a mark deduction, right? So make sure you don't round too soon if you're still working with it. So you add them up, and I will go ahead and do that. And it might be slightly off. Okay, your answer, okay, tallest building, thank you. Remember a statement if it's a word problem, is 72.96 meters tall. Does this vary? I'm fairly sure it varies from what they gave you in at the end. Don't worry about it too much if you follow this method. And nobody can take marks away from you for being more accurate, right? If you're including more decimals, if you included all decimals, right, and that got you a little bit of a different answer, I would say, well, that's even better, right? And so keep that in mind. So there we have that word problem, which is a classic, to be honest, but don't be too fixated on it's always going to look this way, okay? They're always going to give me 50 here. They may give you some other pieces in here that you need to consider. So read, label carefully, and proceed with caution, right? Like, what am I supposed to do there? Let's do one of these. Anybody like me to do one in particular? A or B? Let me know in the chat. Would you like me to do A or B? Which one would you like me to do? Let's see if you're awake. A or B? Type it in the chat. Loveline says B. B, B. Okay. Okay. Thank you. Anybody know A's? Okay. What I need you to I want to warn you about this. This 12 is that sliver. Okay. And you cannot work, not this year. If you're with me in grade 11 applied, or if you take pre-cal, you can work with an oblique triangle. We call anything that isn't a right triangle, we call oblique, okay? But you cannot. So you have to split this into 2 right triangles, right? So you have the big one. So it's 44 and 12, right? That's 66 degrees. And then you have 15 here, and UX, right? UX. That'd be the first one. And then the second one, you have the 44 there. And this is UZ. Okay, and this is still 15 here. So they want this here. It's like the kite question on the test. Okay, I'm just gonna leave it at that. Let's do B here, because that's what you were asking for. I'm gonna write on this diagram here. So find the length of BC. So we know, let's analyze this. Okay, what can we gather from this? Okay, I know most of the information lies in this triangle here, so that's going to be my starter. I'm going to find the side that they share and then move on to the second triangle. Okay, you need right triangles. So start with triangle 1, right? I'm going to call this X, and I'm going to call this Z. Okay, the stretch from here to here, I'm going to call that Z, because that's ultimately, when it's 2 triangles, I like to use XY or XYZ, whatever you need to do. So I'm going to start with this one, and that's X, or DB, right? So we know that this is 23 degrees. This is 13.5 inches. So let's go ahead and find the one they're sharing. So based on this angle, this is the opposite. Don't know, don't care. And this is the hypotenuse. O h, that's sine, right? So sine of 23 is going to be the opposite over 13.5. You cross multiply and divide, so it's 13.5 times sine of 23. And it doesn't matter if you go sine of 23 times 13.5 or vice versa. I always like to put the number in front, just in case you have your calculator does something weird, because if you go sine of 23 times 13.5, it might take the 23, multiply by 13.5, then take the sine of it. And so I just like to always have the number, the coefficient multiplying first, okay? So it's 13.5 times sine of 23. And I'm not done yet. I'm going to use that. So 5.2749 if you round to 2 decimals, and we're in inches. Okay, important to me. Move over to the second one, right? Now, triangle 2, right? What do we know about that triangle? Well, we know that this is Z, and we just found that this side is 5.2749 inches. And watch this. This is where I was talking about earlier. If this is 41 degrees, okay, it's a little bit hard to see because of the highlighting, right? It bled through the page. But if this is 41 degrees, you can either subtract that from 90 to get this one, right? Which is going to be 49, right? Or remember I told you that this is the angle of depression technically. You can transfer that over and say that this is 41 here. Or say that this is 49 there. It doesn't matter. Either one will get you the exact same answer. So if you deal with this one, now based on this one, this is the opposite side, right? And this is the adjacent. This is my don't know, don't care side. So I need to use TOA, right, or tan. Don't tell your teacher ever, you got to use TOA, right? Next year, they're going to look at you funny. It's not right. TOA is just to help you determine which one is it, sine, cosine, or tan. But you're using tangent here, okay? You're not using TOA. So tan of 41 degrees is equal to 5.2749 over Z. Or you can call this BC, right? Don't let that throw you off. And now I'm gonna just scroll up a bit. And so here you cross multiply and divide. So it's Z times tan of 41 degrees is equal to 5.2749 because there's just a 1 multiplying it. You divide both sides by tan of 41. Like that. And then you come up with your answer. 5.2749 divided by tan of 41. That's 6.07 if you round it. And we are in inches. Side BC is equal to 6.07 inches. One more time, okay? I don't even know what the answer is. I'm just going to peek and make sure I'm actually on the right track here. Yeah, it says 6.07. Your answer right there. BC is 6 inches or 6.07. Round to 2 decimals, even your angles, okay? 2 decimals. All right, there's B for you. Let's move on now to chapter 6 and 7. Okay, maybe some of the things I'll just mention. Right, this we did. So they're basically giving you the x value here. So if x is equal to 7, -7, you plug it in and you get f of x out of that. So make sure you know how to do those. Using the graph to the right, determine f of -4. So basically they're saying when x is equal to -4, then y is equal to what? That's what this is saying. So when x is equal to -4, y is equal to -2. Okay, I'll just glance over some of these. Calculate the domain value if the range is -1. X is your domain, y is your range. So they're basically saying when y is equal to -1, what is the x? And it's 0 here, right? State the x and the y intercepts as coordinate points. So the x-intercept over here is 4, 0, right? And the y-intercept over here is 0, -1. Okay? You need to also remember that. Go review that. X-intercepts, y is equal to 0. The y-intercept, x is equal to 0. Okay? Calculate the slope using the intercepts of the formula. Okay, so for D, I'm just going to do that here. I'm basically going to use these 2 points. So I have 4, 0 as one of my points, 0, -1 as the other point. It says calculate, okay? I can already tell just by looking at the graph that this slope is going to be positive because it's going up. And then it's going to rise 1 and run 4. So it's going to be a positive 1/4. I'm already predicting that. I know that, but if I need to calculate it, you need to show your work here. So we know that slope is y2 minus y1 over x2 minus x1. Okay, the difference in rise or vertical, right, over distance, horizontal distance. Okay, and that's also called the rate of change in the word problem. So don't let that throw you off. Okay, there would be units attached to both of them. In this case, there are no units, but I'm going to go x1, y1, x2, y2. This is just a good reminder of how to do this, okay? And so slope would be y2, which is -1, minus, make sure the minus comes in here from the formula, minus y1, which is 0, over x2 minus x1, which is 4. Watch double negatives, okay? And you get -1 over -4. I don't like that. I'm just going to get rid of some negatives here. No, right? Like keep them with you. Negative divided by negative gives you a positive 1/4. So you're done. State the slope parallel to this line. A slope parallel would be 1/4. Same slope. F, state the slope of a line that would be perpendicular to this one. And so you slope that would be perpendicular. You change the sign of it, so it's positive, so we're going to go negative. You flip it, so it's -4/1, which is just -4. State the equation of the graph, line, and slope-intercept form. Slope-intercept looks like this. Looks like it. It could have the b missing, right? Y is equal to, the slope is 1/4 x, and my y-intercept is -1, right? So that's how you would write it there. State the equation in general form. So we're just going to use this and write it in general form. Okay, so let me just take it from there. So I'm going to just slide down a bit. Are you awake? I know it's tough, right? I'm going to use this one here. Y is equal to 1/4x minus 1. Just apply your knowledge of, right, algebra here. And so I'm going to maybe bring everything over right away. So this quarter x comes over -1/4 x. The y is already there. I'm just going to say it's positive, it stays, and the -1 comes over, adding, equal to 0. I'm going to multiply this whole thing by -4. Okay, I'm going to multiply this whole thing by -4. Why negative? Because I want this to be positive. I don't care about the rest. And 4, because that's the lowest common multiple of all the denominators, right? All these other ones have a denominator of 1. So that gives you x minus 4y minus 4 is equal to 0, right? You want everything on the left, you want a to be positive, and you don't want any fractions. That's the definition of general form. Got it? All right. Hold on. Hold on. One last kick of the can here. HI, right? Point slope. Write the point slope form of this thing. You do not pick, don't pick the y-intercept when you do this one, okay? You just want to pick another point on the line. It could be this one right here. It crosses perfectly, or the x-intercept, but I'm going to use this one here. My one point that I have is -4, -2. And the slope I know already by just looking at it is 1/4. So point slope is y minus y1 is equal to slope times x minus x1. Okay? And then you just plug in. It will be the opposite sign, right? Because it will be negative and negative goes positive is equal to 1/4 x, negative and negative will also be positive. So that would be a point slope form. You have the point here and you have the slope. You could rewrite that into general, you could rewrite that into slope intercept, right? This is the best one to get you started and then go into either direction. Or you can go general or you can go slope intercept from here. Okay? You happen to know exactly what the y-intercept is. So it's easy to also write the y-intercept form just by looking at the equation. But if you do not cross at an exact intersection, if you don't know exactly what the y-intercept is, you should start with point slope. You should pick a point that you can actually pinpoint and then go from there. Okay? Where are we at? You know what? Is there anybody out there have a specific question on any of these ones here? I will let you write that in the chat. Anybody saying, you know what? Out of all these questions, I want you to do this one. If a couple of you or one of you want to type that in before I continue, I will do so. All of these we have done. Okay. What I'm going to do here is state the domain and range in both forms for all of these. One last kick at the can of domain and range. Okay. And so let's figure out the domain of this one. And this one is actually finite, right? It has a beginning and an end. So let's do set notation. We go from x is 0 inclusive to 4 also inclusive because we don't have any open dots. That would translate to 0 to 4 interval notation, square brackets on both sides. The range would be squiggly black brackets from 0 inclusive all the way to 2 also inclusive. That would make it 0 to 2 using interval notation. Is this a function? Nope. Function. It's not a function because the vertical line test, it fails it, right? It doesn't pass the vertical line test. This one, I'm going to have to go all the way out here to come up with a domain and range. the domain goes from -2 inclusive to x is 3, but it's not inclusive, it's an open dot. So in that case, I just do less than and 3. Okay. And this would mean that if I write it as interval notation, it would be -2 to 3 round bracket, because 3 is not quite included. It's hard to see, but this is an open dot. Okay, let me just zoom in there. You can tell that it's supposed to be an open dot. I'll make sure that on a test it would be very clear. And then your range here goes from y0 to y of 3 as well. So we go 0 inclusive, y less than 3, like that. So that'd be 0 inclusive to 3 round, like that. What I don't have here is I don't have the domain and range of just points. I have one example here on the side, which I might do. Domain here, running out of room, so I'm gonna have to be conservative. This one is tricky, right? My x, I'm looking at the x and kind of like say what's the lowest x value that I get, and that's -3, and it's inclusive. And the highest x value that I get is 6. Okay, inclusive. So this would be -3 to 6 square brackets if you write the domain of that. The range, what's the lowest y value I get? And that's -6 inclusive, all the way to the top here, which is 5, also inclusive. So it's -6 to 5, both inclusive, like that. Okay, so you get that point there. Maybe I'll just throw this in there. I got this from your test, actually, that you wrote. Something like this, if you have, this is discrete, right? You cannot write it in interval. Okay, this can only be written as in set notation. So for x, it would be 1, 2, 3, 4. Okay, and for your range, it would be 2. You do not repeat, right? It's 2 and 3. That's it. It's 2 and 3. That's it. Okay. So, and that would be a function because it passes the vertical line test. Just wanted to throw that in there. Don't worry about calculating the midpoint, right? You just calculate the slope here. Make sure you practice that. It's the sign that is going to be crucial. Don't worry about 7. And then here again, calculate the slope, right, of 2 points, very important. And then if lines are parallel, what's the slope of the other line, and so forth. Make sure you practice that. I'm trying to think here. Determine the slope point form of the line it's missing, right? Of the line that passes through these points. How would you do a question like that? Well, you have points, all right? You have 2 to pick from, but you need the slope, right? So you're going to call this x1, y1, x2, y2. So your slope would be 10 minus 8, and then 10 minus 6, and that would give you 2 over 4, which is 1/2. Make sure you reduce your fractions. Okay, so you can either pick this point now or that point as the point that you're using for the slope and slope point, or point slope. So y minus 10 is equal to 1/2 x minus 10. right? I use that one there. Or y minus 8 is equal to 1/2 x minus 6. Both of these will give you the exact same line. And you could confirm that by rewriting it to either general or slope-intercept. You would see that they're exactly the same. Okay. How about this one here? I'm almost done, folks. 20 minutes. Okay. Find the general form, that's what they want, of the line that passes through this point and perpendicular to a line with a slope of negative 2/5. So a lot of things here. Okay. First of all, if you want the line to be perpendicular to that one, you would need to find the slope that is perpendicular to it. And you really just change the sign and flip it. So that ends up being 5/2. Okay. Change sign and flip. Right? Those are the two. Those are 2 steps you need to take to find a perpendicular slope. The point that you're given is 3/6. Slope, point, right? Point, slope. You have what it takes. So we got to use this one. Y minus 6 is equal to 5/2 x minus 3. That would be correct, but you want it in general form. So notice what I did. I found the slope perpendicular. It needs to go through this point. So I used these as my values here. I changed the sign as I plugged them in. And now I need to get it to general form. They could have asked for the slope intercept. The initial step is the same. Okay, so let's get rid of the 2. Multiply this by 2. Multiply this by 2 like that. Okay, so you get 2y minus 12. Here you cancel out, and so you distribute the 5. That's 5x minus 15. And here you got to see, what do you want? You want general? Okay, then I need to bring everything over to one side. So the 5x comes over negative. The 2y is already there, keeps its sign. The negative 12 is here. The 15 comes over adding, and now you have everything equal to 0. Okay, I'm going to clean that up. Negative 12 and 15, that's plus 3, is equal to 0. Multiply everything by negative 1. And so that's 5x minus 2y minus 3 is equal to 0. Done. You could have over here branched out and found the y-intercept form. Okay? Y-intercept form, or slope-intercept, sorry. I don't know what I'm doing here. I should know by now, right? Slope-intercept. We go this way. 2y is equal to 5x minus 15. The 12 comes over adding. Okay, so I'm now isolating y. And so 2y is equal to 5x minus 3. Divide everything by 2. And that's 5/2x minus 3/2. Right, so that would be the slope-intercept form. Okay. Of a line, this is the line that goes through this point and is perpendicular to the one they were giving us, right? So they could have given you an equation and is perpendicular to this equation, right? They could have given you an equation that looks like this. Okay. And you're like, okay, it has to be perpendicular to that. Still same order of business. I'm going to change the sign and flip it and then go from there. Okay. Okay. I want to do a system. Explain the 3 types of systems. What are their names? How many solutions do they have? what do they look like on the graph? So you have one solution. That's when they have different slopes and they meet, right? Then they will meet. They have one point that they share. You have no solution. That's where the slopes are the same, but the y-intercepts are different, right? They run alongside each other. They never cross. No solution. Then you have equations that are actually exactly the same. You just see a pattern that to get from the first one to the second one, it was multiplied by a constant. Make sure it looks different. Don't give me another equation that looks the same. And so they have infinite, they coincide, it's the same line, infinite number of solutions. Okay, so that's, you need to remember that. 14, solve the system by using the method requested. I'm going to jump straight to the your choice. Do the hardest one. This is the grand finale. Okay. This is the last question that I will do for you before the cumulative. Ready? Okay, so I'm going to write this down. Last time you have to hear my voice. Okay, 3/4 x plus 1/8 y is equal to 3. Okay, so this is probably the, well, there could be a decimal question, right? You could have decimals. If you have decimals, you just multiply by 10 or by 100 or whatever. But you want to get rid of decimals. You want to get rid of fractions, if at all possible. And so you look at the denominators and you pick the lowest common multiple, which is in this case 6. 6 is the one that they're going to share in common, right? If you were to do the multiples of each. So I'm going to take this one, I'm going to multiply that by 6, and that's going to get me an equation that is easier to work with. Still going to be the same line, just a different equation. And then this one, the lowest common multiple is 8. So I'm going to go times 8, and I'm going to figure out what that is. Okay. So 6 times 1 is 6, divided by 2 is 3. So that's 3x. 6 times 5 is 30, divided by 6 is 5, right? The 6's basically cancel out. And then 6 times 24, 6 times 4 is 24, 6 times 2 is 12. That's 144. Use your calculators because you technically have them available to you. Here, 8 divided by 2 is 8 divided by 4 is 2. 2 times 3 is 6, right? So that's 6x. This would just be 1, right? So that's positive y. Make sure you don't get you don't mix up your signs, okay? So now it's a lot cleaner. It's a lot easier to deal with. Okay. So let's go. What do we do from here? We have choices, okay? I'm going to do substitution method first. Okay. So I'm going to, from here, I'm going to make an arrow. I'm going to derive from here. I'm going to isolate y because I see in this system, this has a coefficient of 1. So I can just say, hey, y is equal to 6 comes over, that's negative 6x, and the 24 is already there. So I've rewritten this equation to that. I'm going to plug this into the first one. Arrows, I love arrows, right? They kind of tell a story, right? So you isolate it, use substitution method. And I'm going to do elimination as well. But you basically, this here, okay, you're going to plug that into, you have to, if you isolate the second one, you have to take it and insert it into the other one. You can't insert it into itself, okay? So we're going to go 3x minus 5y, and y is negative 6x plus 24. Take your time on these ones, okay? 1 is equal to 144. And then we have 3x minus, negative and negative is positive, right? So it's 30x. And then you also, right, you have to distribute. That would be negative and a positive is a negative. And that gives you 120 is equal to 144. Add up your x's. 144, the 120 comes over adding. You have 33x is equal to 264 over 33, because you divide both sides by 33, right? And x happens to be a nice round number, which is 8. Keep going. You can plug 8 into either one of the ones you have there, or into the original if you'd like. So I'm going to do 6 times 8 plus y is equal to 24. I'm using this one right here because it doesn't matter. Once you have x, you can plug it into either one of them. So that's 48 plus y is equal to 24. Y is equal to 24 minus 48. And so y is equal to negative 24. We're going to verify. Verify. So pick the original. Using the original equations, because that's when you're going to find out, oh, I made a mistake. Because if left-hand side is not equal to right-hand side, you made a mistake somewhere. So I'm going to go with the first one. 1/2 8, right, minus 5 over 6, and y is negative 24. Is supposed to be 24. So I'm just doing it like that. I'm not doing the bar anymore, left-hand side, right-hand side. I'm just taking this first equation, plugging in x and y, and I'm going to see if it actually equals, right? If both sides are equal. So 8 divided by 2 is just 4. Here you need to make sure that these two will ultimately end up as a positive, right? And so I'm going to go 24 divided by 6. That's 4. 4 times 5 is 20. 24 is equal to 24. Check. And then I'm going to take the second one, which is 3/4 x, and x is 8, plus 1 over 8y, which is negative 24. That's supposed to be equal to 3. 8 divided by 4 is 2. 2 times 3 is 6. This will ultimately give me a negative. 24 divided by 8 is 3. 3 is equal to 3. Check. Now, I know that the solution, therefore, solution is 8, negative 24. Then you can state it. If you ask to verify, after verifying, I would always encourage you to verify regardless if I ask you or not to show it, because it just confirms what you found. I'm going to do elimination. Okay, that's the last one I'm going to do here. I'm going to do the same one, but now I'm going to use the elimination method. Okay. Using elimination method. So I'm going to cheat and copy that the two that I got when I got rid of the fractions, like that. So let's say you got rid of the fractions, which you should do anyways. You got rid of the decimals, which you should do anyways. And now you had a choice and you wanted to use the elimination method. You need to multiply both or one of them by a coefficient so that when you add, I always like to add them. You can subtract, but then you have to be very careful with the signs so that things cancel out. And I see that 3 and 6, right? If I multiply this by 2, I would get a 6. So what I'm going to do is I'm going to take the first one and multiply it by negative 2. Okay, not just by 2, by negative 2, which would give me negative 6x plus 10y. You got to be careful, or else you're going to get a 0 out of out of that question. You don't want that. Oh, almost missed this one. 2 times 144, that's negative 288. Okay? Negative 288. Almost forgot that. And I'm just going to bring this over. No changes made. Not doing anything. And now I'm going to add these two equations. And this is going to cancel out because negative 6x plus 6x is just 0. If I add these, I get 11y is equal to, you get negative 264, right? Yeah, like that. And so you divide both sides by 11, and you get well, we're supposed to get negative 24, right? But just using your calculator, you will get a negative 24 there. Now you can use this and plug it into either one of them. Okay? So you can go 3x minus 5 times y, which is you just found out is negative 24, is equal to 144. 3x is equal to, 3x plus, because these two negatives gives you 120. It's equal to 144. 3x equal to 144 minus 120. 3x is equal to, you get 24 there out of that. Divide both sides by 3. X is equal to 8. And we won't verify again because we already know that that's correct. But this is using the elimination method. Okay.